All right, 4.6, continuing on with the notes that unexpectedly stopped prior to this one. So part 1 at the end there, it stopped recording and I didn't realize it. And so I'm just going to kind of pick up where it left off here. So we were talking about on example 4a, we were graphing y equals sine of 2 theta. And so we said it was sine, and so we were using our parent sine table. Remember, sine starts at 0 in the middle, and it goes up, and then it has to come back down, and then it goes back up. All right, so when we actually graph this transformation, though, it says 2 times x. And so we know that means we're going to take our x's and we're going to divide by 2. Or we could say that's the same as multiplying by 1/2. And so my y's are all going to stay the same, so I'm just going to copy them down. And I'm going to multiply all of my x's up here by 1/2. So 0 times 1/2, whoops, I'm thinking ahead. Pi over 2 times 1/2 is pi over 4. Pi times 1/2 is pi over 2. 3 pi over 2 times 1/2 is 3 pi over 4. And then 2 pi times 1/2 is just pi. And so when we go to graph that, we got 0, 0. And I don't know where pi over 4 is necessarily, but I know that pi over 2 is right here. And remember, these are all equal distance from each other. So that means that pi over 4 is halfway between 0 and pi over 2. So it's going to be this little line right here, and it tells me that the point is up at 1. And so then, I don't know where 3 pi over 4 is, but pi is right here, which means 3 pi over 4 has to be directly between pi over 2 and pi. So it's right there on that line, and it's down at -1. And so here is the graph of our function. Now remember, if we want to continue this, we can follow our pattern. This leftmost point here is the same as the rightmost point. So to get to the next one, up here at the top, we went right 1, up 1. And then from there, we went right 1, down 1, right 1, down 1, and then right 1, up 1. And so we could continue our pattern indefinitely here. All right, in example 4, we have y equals cosine of x over 2. And so we know we're going to use our cosine parent table. Cosine starts at the top, so then it has to come down to the bottom and go back up. Now, for this, we see it says x divided by 2, so we know that means we're going to take our x's and multiply them by 2. So my y's are going to stay the same, and all of my x's are times 2. So 0 times 2, pi over 2 times 2, pi times 2. Well, wait, if I have 0, 1 pi, 2 pi, we're going to get 3 pi and 4 pi. And then you could check it. Check your last one. What's 2 pi times 2? It is 4 pi. All right, and so we can graph this. So we got 0, 1, pi 0, 2 pi -1, 3 pi 0, and 4 pi 1. And so we can see it's just a longer period there. All right, so it says, can you describe what happened to the graphs? The periods for each of these two functions is 2 pi over b. Because one full cycle will be graphed in this interval. In general, we can say that if y equals a times sine of b theta, or y equals a cosine of b theta, then the period is found by 2 pi over b. That's important, guys. To find the period for sine and cosine, or their reciprocals, you're going to take 2 pi and divide it by b. All right. So for example 5 here, it talks about a phase shift. It says a phase shift is a trig function, is a horizontal transformation of the graph's initial point. So the phase shift is only the transformation of the initial point, okay? And so when we do this, we can see that we got y is equal to sine of x minus pi. So we know we're using our sine parent table, And for our x's, we're actually going to add pi. All right, so for sine, remember, starts at 0 and goes up. So my y's will stay the same. And my x's, I'm going to add pi. So 0 plus pi is pi. Pi over 2 plus pi. Well, we may have trouble with that one because remember you have to have a common denominator to add or subtract with fractions. But remember, in your calculator, just don't put the pi in it. So that's a 1 pi over 2. So in my calculator, I would put 1/2 plus, that's a 1 pi, so 1. It's going to give it to me as a decimal. I'm going to tell it to change it to a fraction. And then I'm going to take and I'm going to put pi back in my answer. So I know that it's 3 pi over 2. All right, then I keep going. So pi plus pi is 2 pi. And then I would take my 3 pi over 2 plus pi, which is going to give me 5 pi over 2. And then 2 pi plus pi is 3 pi. And we can just graph that. Okay. And the same thing with the cosine one. We're just going to subtract the pi from it. And what we notice here, let me go back to 5a real quick, is notice this just made our graph go to the right pi, which we know using transformations, that's what's going to happen there, okay? And the same thing here. So we know that this is going to make our graph go to the left pi. It's telling us what's going to happen. Now, what we don't have an example here is if we had something with a b value in it as well. So it says here in both examples, the phase shift is pi. And they get that because in general, we can say that if y is equal to a times sine of bx minus c, or y is equal to a times cosine of bx minus c, then the phase shift is found by taking b divided by c. So when the argument is bx minus c, then remember, because the minus tells us we're going to go to the right, so it's going to shift our graph to the right. And if it's bx plus c, the plus in front of the c tells us we're going to go to the left. And then the last thing here we've got is the midline. The midline, it says if you add or subtract the number from the entire equation, you can shift the trig graph up or down. This is a shift in the x-axis, and it creates a new midline for the graph. So it's a line in which my graph is now going to be centered on. And so I'm just going to work, I'm running out of time here, but I want to make sure I get this video for y'all. So I'm just going to work 6b real quick here. So we're going to take cosine of x, and we're going to subtract 2 from all of our y's. Because it says minus 2 there, so that's going to affect my y's. So my x's would stay the same. And my y's are all minus 2. So 1 minus 2, 0 minus 2, negative 1 minus 2, 0 minus 2, and 1 minus 2. All right, so when I graph these, oops. I get this as my graph, okay? So what I notice here is, remember, before they were all centered up here. Now the middle of that graph is right here. You have your top points, you have your bottom points, and then you have that midpoint. That is your midline, okay? That's what it's centered on. And look, it's no coincidence that it's centered on that D value, okay? That's going to be our midline. So it says, therefore, if y is equal to a sine of bx minus c plus d, or y equals a cosine of bx minus c plus d, then the vertical shift of the entire graph is equal to d. So the midline of the graph is y equals d.